Lesson 3.5. Perform basic matrix operations. So matrices are kind of new. We did them in geometry, but now we really get to focus on them. They're used to organize data and use a lot in computers. For example, a computer desktop wallpaper known as a bitmap is a matrix. Each element tells what color pixel goes into that spot. The math definition is a matrix is a rectangular arrangement of things, variables or numbers in math, such as this. That's a matrix. The dimensions are the size of the matrix, and we always do it rows by columns. So up above, we've got 3 rows, 1, 2, 3, and 4 columns. Rows go sideways, columns go up and down. Because, in buildings, these things that hold up a roof, the Greeks liked them, they're called columns. Columns go up and down. In order for two matrices to be equal, they must be the same dimensions, and the corresponding elements, those are the numbers in the matrix, must be the same. These two matrices are equal because they are exactly the same. So if these matrices are equal, then we can find the value of all the variables. I've color-coded them. So we're going to take the top left element equal to the top left element. So the 2 equals W. To find the y's, the top right element is the top right element. Make them equal to each other and solve for y. We can do the bottom left, and make those equal to each other and find x. And lastly, we can do the bottom right, the 4 equals to the z minus 4, which is also in the bottom right. And you get 8. Make sure they're in the same spot. Adding and subtracting matrices. To add and subtract matrices, they need to be the same dimensions. And when you add and subtract, you need to add the corresponding elements. So it's like the top left with the top left. So here's an example. We're going to take the top left and add it to the top left. 1 plus -2, right there, top left. Top right with the top right, 2 plus 5. Bottom left with the bottom left, -5 plus 4. And the bottom right with the bottom right, 4 plus a -3. And then we can simplify. 1 plus the -2 is -1. 2 plus 5, 7. -5 plus 4 is -1. 4 plus -3 is 1. Here's another example. These matrices have 1 row and 2 columns. They're all the same size, so we can add them. So just take the first one with first one, first one. So we have the 2 minus 3 plus 1. Then we'll have -3 minus 4 plus 0. And simplify. First part gives us 0. Second part gives us -7. Or here's another example. Notice our first matrix is a 2-row, 2-column. The second matrix is 2-row, but 3-column. So we can't add these because they are different dimensions. We can multiply a matrix by a scalar. The scalar is just a number that's not a matrix. So like being multiplied by 2 or multiplied by 3. You do it, it's just the distributive property. You multiply then all the elements by that number. For example, we are going to take this 3 and multiply everything by the 3. And we get this, so it's 3 times everything. So 3 times 5 is 15, 3 times -2, and so on. Here's a word problem. The National Weather Service keeps track of weather. Imagine that. So we have days of weather in Benton Harbor and South Bend in 2014. Days of precipitation, days of that's clear, and days with an abnormal temperature. So what is the meaning of the first matrix plus the second matrix? Well, since the first matrix is June and the second matrix is July, when we add them together, it'll probably give us the total weather for both months combined. Total number of days of each type of weather for each city. Use matrix operations to find the total weather stats of each city. So we're going to add the two matrices. So take the first matrix and add the second matrix. So take the first one and add the second one. So I'll have 3 plus 14, right there, top left. 18 plus 15, right here, top right. 16 plus 18, middle left. 13 plus 18, middle right. 12 plus 2, bottom left. And 19 plus 8 on the bottom right. Okay. Then simplify and you get this for your resulting matrix. And here is your assignment. Have a good day.